Might not have finished all those. Okay. This is the first question. This is part of the worksheet. So I assume all of you must have read this question. And some of you must have tried and solved this question as well. Okay. So Tejas, can you tell me how did you solve? You said you have solved majority of the question. Tell me what is the best way to solve this question? And what are things we should keep in mind?
So the best way I solve this question is by using conservation of mechanical energy, sir, from height h and to distance s, right? So
okay, one is conservation of energy. That's one way to solve. Using laws of motion, Vignesh, how did you solve this question?
So even I use conservation of energy.
No, so this is something, see, same question. That's why I took up this question. I understand the difference. It is dropped from a height edge. It means, suppose we take a wooden surface here. Let's see what are the different ways we can understand. So there's a wooden surface, a knife is dropped from a particular height. So this knife edge is dropped from a particular height. So what will happen for height h? It will accelerate and then it comes to stop in distance s. What is happening? This also, if we look at in terms of kinematics, this question is accelerating for distance h and then deaccelerating over a distance s, right? Is it not? That's what is happening. So whatever velocity it gains in distance h, same velocity it loses in distance s. So here there's a downward acceleration g. So and here there's a retardation a. So do you think these four quantities are related here, Vignesh?
Yes, sir.
Can you think of this also? I'm just looking at what are the various ways we can analyze a question. So this question here is from here, it is falling here, and moment it touches the surface here, because the resistance offered in distance s, it comes to stop. So if I analyze from kinematics, you can do from kinematics. The kinematics we can find out acceleration. Once we can find out acceleration, then I can apply laws of motion to arrive at force. So not from conservation of energy, from this measure also. So if I look at VT graph, can you all visualize how would the VT graph be? Jaideep, can you tell me what will the shape of VT graph?
So the particle initially undergoes acceleration, sir. So
will it be a straight line or a curve of VT graph?
Straight line, sir.
A straight line. So basically, for until it hits the surface, this will be a straight line, and this slope will be equal to g. And this area, what is there under this curve, this area is equal to h. Is this clear?
Yes.
And from here it is retardation. And retardation, this area is s. Height is same. Okay, height is same. So this is another way you can look at this. Can we relate these two quantities? How are A and G related? Can we find relationship between A and G? So if I write a relationship, this point velocity is v. V square is equal to as, basically read 2g into h, and then in second part this is 0. This will be equal to v square minus 2as. V square is same. If v square is same here, basically 2as is equal to 2gh. So basically what we understand here, A and S quantity are in the same. So if it falls for a distance of 10 meter, it comes to stop in 1 centimeter. If it falls for say 100 centimeter, it comes to stop in a 1 centimeter. Can you tell me, Jaideep, what would be retardation here if it comes to stop in 1 centimeter? Is the retardation related to heights?
Yes, sir.
How much this will be? Something else also we can notice here. Vignesh, can you tell me what is the retardation here? If acceleration is g and this distance 100 centimeter, if the ratio of distances are given, do we know the ratio of accelerations also?
So like it will be 100g, right, sir?
100g. Straight away we can look at 100g. So that's another we can understand here. So it comes to in that distance. So basically acceleration will be, how much will be acceleration? Will be that many times more. Once we find out, that's another way to analyze. So what would acceleration be? So g, it will be g into h by s. That's acceleration. But this is acceleration. So now understood from here to acceleration is this. Acceleration is acting in the upward direction. This is acceleration. And what is the free body diagram? What are the forces acting? Forces acting are two here. What are the forces acting? Force of resistance offered by the wood and mg. These are the forces acting. If I write the equation, how would I write the equation? Resisting force minus mg is equal to m into a. So what is the resisting force or resistance offered by the wood? It will equal to g plus a. That's what we need to find. So I hope this is another way. Jaideep, have you followed? Even not only conservation of energy, there's another point also we notice. You know, it's something when it accelerate and deaccelerate, the ratio of the magnitude of acceleration is inversely proportional to the distance. We can quickly use in some of the cases. And okay, inversely proportional. Next question. Are we clear about this? Who all have solved this question? Just have you solved this question?
Yes, sir. I solved that question, sir.
Do you clearly understand this question?
Yes, sir.
Tell me, how do you solve this question? And rest of the people also please follow. So how do you solve this question? What basis, what principle, and what are the steps?
So we know the force is nothing but change in momentum by time, right, sir? That is
change in momentum by time. And so
yes,
basically, see, force is equal to rate of change of momentum. So what is force equal to? Force we should write is equal to dp by dt.
dp by dt. Yes, sir.
But if a force is constant,
Yes,
force is constant, then only you can write is change in momentum by time interval.
Time interval, yes, sir.
And this, if it is constant, we can also say, if I can change, another way to define the force is, we can define the force when it is constant is equal to change in momentum in 1 second. Change in momentum in 1 second. What is force equal to? Equal to change in momentum in 1 second. That is sometimes because some people find it comfortable to use this one. What is the change in momentum in 1 second? And that is equal to force. That's another way to understand here. Now it becomes easy. What is the change in momentum happening in 1 second here?
M into n into v, because there are n bullets fired per second.
So basically, n bullets which were at rest, they acquire a velocity v in 1 second. So
Yes.
momentum acquired by n bullets is equal to force. And n bullets, each one acquires a momentum equal to mv. That becomes my force. So that's another way to look at. So what are things we notice here? Force is rate of change of momentum. When force is constant, I can take momentum by time, and we can also interpret as change in momentum per second. That also is sometimes useful. Okay. Okay. How many of you have done this question? Please raise your hand who have done this question already. This is a question which has come in 2019. This sheet was sent. How many have solved this question? 1, 2. How many people have solved? At least I get an idea how many are giving a sincere try. Except for 2, nobody else? None have solved? Dhanshri, have you tried solving this question?
I didn't come to this question yet, sir.
You didn't come? That's okay. Who else? Nobody else other than these 2. Ahlad?
I didn't do.
Why? It's too simple or what? And so very few of you. So Ahlad, can you tell me how to solve this question? Please read through. And that's what I suspected. So can we identify, Jaideep, did you try solving this question?
Yes, sir.
Could you get an answer?
Yes, sir.
Okay, you didn't raise your hand. Bhavishri, can you solve this question?
Yes, I am trying it.
Rest of you also, please give it a try. The problem is rest of you, majority of you are not done except for 2 or 3 people. Arij, did you solve this question?
No, sir.
Why not, Arij? So let's, for those who are not done, I think what happens now, since rest of the people have not done, it becomes a little bit of wastage of time for people who have done. This kind of mesh is there. You can visualize what is happening. And water jet is not a plate now. So that's the variation they have done in mains examination. So here, liquid density is coming through hose pipe. And velocity is v. Area of cross section, radius is a. Okay, those who have solved, Vignesh, can you tell me step by step how did you solve it?
Yes, sir. So the initial momentum will be rho AV square into I cap if we take it in that direction.
First of all, see, basically when we talk about initial momentum of what? This is continuous mass system. What have we defined as momentum as?
Sir, it's the mass striking per second. So the mass within
so
a
basically,
distance of
again, in this case also, what are we doing? When we are calculating pressure or force, we are taking this pressure and force is equal to, so this is okay. So we are calculating momentum in 1 second. Okay. So what is the initial momentum? So what is the initial momentum taken? Momentum is equal to, in 1 second, is equal to mass flow rate. Do you all recall what is called mass flow rate? Whenever a liquid is flowing in a pipe, mass flow rate is what is the mass which is passing through any cross section in 1 second is called mass flow rate. And mass flow rate is something we can call as delta m by delta t. And mass flow rate is equal to rho times volume flow rate. And volume flow rate is area of cross section into V. So this is something we should always keep in mind. So in this case here, so when I calculate momentum, which is incident momentum or momentum which is passing through in a second, or momentum which is passing through the mesh in a second, will be equal to rho AB. That's the momentum which is, this is the mass which is passing. So what is the momentum? It's mass into velocity, rho AB square. And which direction I cap. So this is initial momentum. Then
to find the final momentum, like it's given in 3 parts, right, sir?
Yes. So let's mark this figure here. So this is something, this is my initial momentum. Initial momentum direction is okay. So plus minus sign is enough. This is initial momentum is rho AB square. And then final, what is given here? Okay. 50% passes through. What does this mean?
So it's like rho AB square I by 2 I cap.
So how much mass is passing through? This is the mass which has half of it. And it is passing through unaffected. Had they given a different velocity, this figure would have been different. It is remaining unaffected. So there are parts here. This is something 1 by 2 rho AB square. What about 25%?
That doesn't matter, sir, because
this momentum becomes 0. So some part has this momentum, some part has 0 momentum, and the remaining part, it comes back with the same speed. So what is the mass we have to take? What mass? 1/4 of the initial mass. What is the mass? So 1/4 of the initial mass, 25%. Rho AB is the mass. And velocity, it comes back with the same speed. So I'm writing the V here. Had it be coming with a different speed, I would write a different velocity. Which direction? This is negative. So what we do here now? So what we need to find here? So what is the change in momentum? This is initial momentum. We can write final momentum. And how do we calculate force? Force will be equal to change in momentum. And how do we calculate what is area pi square? What will be pressure in that case? Force by area. So I hope all of you can solve it now. Danshi, do you think you can solve it now?
Yes, sir, I can.
Have you understood what is the mass we have taken here?
Yes, sir, I have.
Mass, we are talking about mass, which is mass flow rate. How much mass is passing through any cross section in the pipe? That's the mass which is striking the mesh in a second. That's what we are taking here. So this is an important point. Rate of change of momentum. Next question, next one. So this is also part of assignment. This question, how many have solved this question? Okay. Yes, you solve this question. What is given here? What the instantaneous force?
Yes, so then we have to calculate the instantaneous change in momentum.
Instantaneous change in momentum. We have done it earlier. Final momentum will become 0. Why is the final momentum 0 here in x direction?
Yes, sir, because it'll that one.
Why does the initial momentum? What is initial momentum? Again, we take mass flow rate.
Yes, sir.
Mass flow rate into velocity.
Velocity.
Mass flow rate is rho AV into velocity. Rho AV square is the initial momentum. Okay. After it strikes the surface, initial momentum in x direction. Okay. After it strikes the surface, it moves along the surface.
Yes, sir.
It will have in x direction with same velocity as the surface. Since this surface is at rest, this also in x direction velocity will be 0.
0. Yes.
So that's the final momentum is 0. So change in momentum is equal to initial momentum itself. Change in momentum is equal to initial momentum itself. Okay. But there is, what would happen if, will the force remain same with time or will the force change? Will the force remain constant or will the force change? Will the force remain constant or force change here? If it is kept on a smooth surface, can you visualize what will happen?
It will change, right? So because the distance between the pipe and the block will keep on increasing.
The distance will keep on increasing. That's your reason why I think
Oh no. It will.
The block will get 5 meter per second velocity and then it will become 0.
So what will happen? As soon as the block starts moving, the force on the block will change. Can you tell me why would the force on the block will change? As soon as the block start moving, the surface also will have velocity. Final velocity of water jet, what is striking the surface in x direction, will become same as this velocity. That's one reason. And second reason is the mass striking the surface here per unit time. Will that mass striking the surface remain same or that also will change?
Change.
Mass striking. See, what is the mass which is passing through pipe? Mass which is flowing through is written as rho AV and the value is given. It is 1 kg per second. But after it start moving, will the mass which is striking the surface, will it remain 1 kg per second or will it change? If it starts moving, say with the velocity of 1 meter per second, if the block start moving at 1 velocity per meter, 1 meter per second, will the rate at which the water jet strikes the surface, will it remain same or change? Vignesh, you solve this question?
Yes, sir. It will change, sir.
It will become how much? Moment it acquires a velocity of 1 meter per second. Earlier, the mass which is striking the surface was 1 kg per second when the block was at rest. When the block start moving, by what factor? This velocity is 5, this will become 1. By what factor will the mass striking the surface will change?
So which velocity is 5, sir? Which velocity? Okay, yeah, it'll be 4, sir.
Yes, it will become 80% of the initial mass flow rate. It will, mass which is striking the surface will become 0.8 kg per second. I hope you understand that part. So what will happen? It will initially, it will have larger acceleration, force will be larger. Gradually the force will keep on decreasing. I'll come with this idea. This is something which is used in rocket propulsion also. Why does force change with time? We'll come to that part also. So you have done this question, and I think this is something all of you might have noticed. If you blow a balloon and just leave the balloon open from one end, what happens? The balloon acquires it gains speed, it gets accelerated as the air escapes from the balloon. This is something you would have all noticed. And let me take little time. I'll go through the concept of the rocket also is similar. So let me briefly explain the principle behind rocket propulsion. Okay, rocket propulsion we can have done in the next chapter also, but we can as well do it here. How does rocket work? And sometimes some question may be there in rocket. Let's try and understand that part. See, just imagine, suppose you are there on a frictionless surface. You're sitting on a frictionless surface and you are on a cart, and this cart has several little balls. Very tiny little balls is filled with so many cricket balls are there. And you are in the cart. And you can throw the ball. When you throw a particular ball, you are applying an impulse. And because of the impulse, the ball acquires velocity. So suppose you want to move in forward direction. If you pick up a ball and in your frame of reference, you throw the ball with the velocity u. So what is the velocity you give to the ball? You give a velocity v. Each ball mass is. So as you throw the ball back, what will happen to you? You all understand here, if you throw the ball backwards, the rest of the trolley will acquire a velocity in the forward direction. This is something makes common sense. All are clear about this part? And if we want to, first ball we have thrown, it acquires some velocity. Second ball also we throw, it requires second velocity. And every time we keep throwing ball, it will keep gaining velocity. And what is happening in this process? The mass of the trolley is also reducing. So if we keep throwing ball in a continuous fashion, it will keep gaining it keeps getting propelled in the forward direction. This is exactly the principle on which the rocket functions. Do you see a similarity between what we are talking about here and the rocket propulsion? Does anyone see a similarity between this trolley filled with balls? If I want to gain speed, we keep throwing ball. And whenever you throw the ball, this is particular, you throw the ball when the trolley was at rest. You have thrown the ball back because you have particular capacity to throw the ball at. Suppose you throw the ball at a speed of 20 meters per second. Okay. So when the trolley is at rest, when you throw the ball will be traveling with the negative velocity of 20 meters per second. Let's try and answer next question. After some time, what has happened? You keep throwing ball. This trolley has acquired a speed of 5 meters per second. When you throw the ball, you apply the same impulse. From this particular position, this was the initial position. Now the trolley is moving at 5 meters per second. You throw a ball back with this. Again, you throw the ball back. What is the ground speed? What will be the ground speed of the ball? Can anyone tell me what will be the ground speed of the ball when the trolley is moving 5 meters per second? What will be the ground speed of the ball? When I was at rest, I have thrown the ball at 20 meters per second. I am applying same force. It doesn't matter to me. I'm moving with a constant velocity. I throw the ball here. What would be the ground velocity? Can I even think of it? What would be the ground velocity of the ball as seen from the ground? Anyone?
15 meters per second.
15 meters. Why 15 meters per second? See, when we throw the ball, that's what happens in case of gun and all also. See, when we throw the ball, as ball will leave my hand with a speed of 20 meters per second in my frame of reference. The speed of the ball relative to the thrower here will remain same. That's called relative velocity. So whenever I keep throwing the ball, relative velocity of the ball will remain constant. And similar thing happens in case of rocket also. In case of rocket, see, we don't throw a ball. Suppose there's a rocket here. And rocket, how does the rocket work? It has, in place of ball, it has some kind of combustion system. It has what you call as a flue gas. Gas which is at a through explosion. We generate gas at the high pressure. And depending on the pressure, the gas escapes with the velocity. So velocity of the gas with respect to the rocket is constant. The way the velocity of the ball with respect to the trolley is constant. So relative velocity is constant. So since they are in the opposite direction, trolley is moving in the forward direction, ball is moving in the backward direction, sum of these two has to remain 20. Here also relative velocity has to remain constant. And every time I throw the ball, if mass of ball is say 0.1 kg, every time I'm throwing the ball, I'm applying an impulse is equal to 20 into 0.1 on the ball. It means the ball is exerting an impulse on the trolley in the forward direction. That's why the trolley keeps getting velocity in the forward direction. Now we ask one more question. It's a really interesting question. See, is it possible if we keep throwing the ball, if I have infinite number of balls, is it possible for trolley to acquire a speed of greater than 20 meters per second? Is it possible for trolley to acquire a speed of greater than 20 meters per second? And logically think and answer. Aviru?
Yes, sir.
Do you think the trolley, but basically what is this trolley? Trolley person, and he can throw the ball at 20 meters per second with respect to the trolley. If I keep throwing the ball, do you think it is possible that trolley, so basically is there upper limit to the speed what trolley can acquire? And there's no upper limit. It also acquire a speed greater than 20 meters per second.
If it acquires more speed than that, the ball in ground frame of reference will move towards the right.
Yes. But still, if the trolley is moving at 20 meters per second also, still I throw the ball back, it will have a forward impulse. So there's no limit. Trolley can still acquire a speed greater than relative speed. It will keep moving. And you know what will happen? See, initially, so when it started, initially this total mass was capital M. And after I have thrown 50 balls, what will happen? The mass will become minus 50 into mass value. Mass will have keep reducing. As the mass keeps reducing, it will be easier to accelerate it. And that's what happens in case of rocket. Let's do in terms of an equation. What happens in case of rocket propulsion? The rocket propulsion, let's do that, and it is useful in some other cases also. See, what we observe, there's a rocket here, and let's say there's a small mass dm of flue gas, and rest of the rocket mass is m. At a particular time, it is moving at the velocity v, and in time delta t, this flue gas escapes the rocket, and let's see, so it gets broken into two parts. So at this time, both are moving together at the same velocity. Now later on, I find this mass dm here. This mass dm is moving, and this mass this is moving at velocity u, and the remaining part will acquire, this mass becomes, it acquires velocity, it becomes v plus dv. So as this mass has been pushed back, this has become slower than initial velocity, this has become higher than initial velocity. How would this get affected? In this case, momentum here will remain same as the momentum here. So we can conserve the momentum. So let's write the equation. And since all are in the same direction, we write the initial momentum, the total mass is dm plus m into v. Let me write this expression dm plus m into v. That was the initial momentum. That has to be equal to final momentum mass dm of the gas into u plus capital M v plus dv. dv is the change in velocity in time delta t. So when you see this, in what do we get here? dm into v plus m into v is equal to dm into u plus mv plus m dv. So what if I did, these terms cancel out? Sorry, mv, these terms cancel out. So what are we left with? dm v minus u is equal to mdv. What is v minus u? Someone tell me what is v minus u equal to? If I can say v minus u, it is approximately equal to v plus dv minus u. The change is very small. What is v minus u equal to? It's nothing but relative velocity. V minus u is nothing but relative velocity. So this one is dm, and that relative velocity will remain constant. This is relative velocity into m dv. So this expression I can understand in one more way. If I divide both sides by delta t, this can be written as dm by delta m by delta t into v relative is equal to m dv by whatever delta t, okay, delta dv. And this one is nothing but what? As far as this remaining part of the rocket is concerned, what is this term? This is mass into acceleration. This is equal to like a force. So whenever this is like a force. So because, and what is the dm by dt? dm by dt is the rate at which flue gas is exiting the rocket, rate at which mass is getting lost. So it will behave as if a constant force. If the flue gas is escaping the rocket at a constant rate, dm by dt. If I say how much flue gas is escaping, I say 10 kg of 10 kg per second. That becomes dm by dt. So dm by dt I can call, this is beta. Beta is the rate at which the mass is escaping. At what velocity? V relative velocity is something like 20 meters per second. And that is equal to, that's like a force which will act, into dv by dt. So this is like a force. So whenever any mass escapes from any moving object, the remaining object will experience something like a force. And what is that force equal to? Rate at which mass is escaping into v relative velocity. That's like a deemed force. And as the mass keeps, okay. Now we can do something more from this. What else we can do? When we look at this equation, this is a particular instance. One thing what we understand here, this is like a force. This is a force and we can use in several cases. Second thing what we notice here, I can also relate dm, it's reduction in the mass. So mass m was there, this dm is the reduction, dm into v relative. is equal to mdv. So what we understand from here, change in velocity is related to change in mass. This equation relates to change in velocity to change in mass. Okay, so I can write something like this. It is equal to dm by m equal to v relative dm by m is equal to dv. Should the equation be same sign or should it have negative sign here? Can anyone think of should it have same sign or negative sign? What is dm here? The mass reducing or decreasing, this dm is always negative. We should put a negative sign. And second thing also what we understand here, as the mass keeps reducing, velocity keeps increasing. So this is the equation. If I have to calculate dv is equal to minus this term. So what is change in velocity over time t? So if I relate this one is AK, so at certain distance, velocity was V1 and later on velocity has become V2. And what has to be limit here? What should the limit corresponding to V1 I should write here? What term I should write here? This term is mass. What should be the value lower limit here? What was the mass when the velocity was V1? I can call it as initial mass here. Initial mass when the initial velocity was V1. And this is the final mass. So as the mass changes from initial value to final value, the velocity also will change. So what is V2 minus V1 equal to? Change in velocity. As the mass, as the rocket is moving and flue gas is escaping, this will be equal to minus V relative. This will be equal to delta V. Increase in velocity will be equal to V relative. And I will change the limit here, ln m. And since there was a negative sign, we inverse the limit. So this becomes initial mass and this is the final mass. So what is change in velocity equal to? It is equal to V relative ln of initial mass divided by final mass. This is change in velocity. This is what happens in case of rocket propulsion. Bhagishri?
Yes, sir.
The whole thing is making some logical sense as well.
Yes, sir.
So what happens if you are sitting in a trolley and you have numerous balls, initial mass is m, you keep throwing the ball. Once the whole mass of the trolley has become half, if we know at what velocity you have been throwing, I can calculate what is this value. You can calculate this. Okay, something like this. Okay, so what is the force is exert? Okay, so this is something in case of trolley. This is a simple example. So coming back to this question, here if the balloon shrinks to 5.6 seconds, what is the average force? This particular question is simple. What is average force equal to here? A balloon has a mass of 6 grams. This is more detailed. This is what happens in case of rocket propulsion. Mass of 8 grams, whole sphere. It here escapes at a uniform speed of 7 centimeter per second related to balloon. The balloon shrinks to 5.6 seconds. What is the average force? So in this case, what is the force which something like this is? What is average force? How would you calculate this average force? What is given? The velocity is not given. Relative velocity is given. And as we have seen, average force is equal to dm by dt into relative velocity. And where this expression comes from, this whole expression is dm by dt into relative velocity. So what is the rate at which mass is escaping? Since the rate at which air escapes is constant, so you can write as delta m by delta t into relative velocity. So all terms are given. What is mass here? 8 grams. Delta m is 8 into 10 to the power minus 3. In how much time? In 5.6 seconds. Yes, Vignesh?
Sir, the law of conservation of momentum we should always apply in the ground frame of reference, sir.
See, law of conservation of momentum is based on force and impulse, right?
Yes,
So
sir.
does it depend as long as if we choose a frame of reference which is moving at the constant speed, will it be valid? Yes, it will be valid.
Yes, sir. But in a non-inertial frame?
Yes, non-initial frame, no, it will not be valid unless you apply a pseudo force.
Okay, sir.
So very simple. Mother, when we see, look at this, will it be valid? Yes, we can be valid. You can also apply. And in fact, we don't do because simpler question is not so useful. Certain questions are easier to solve. When you come to some later questions, if once you start preparing for advanced some kind of question, some questions are easier to solve in center of mass frame of reference. So we can also examine some question. How would motion appear in the ground frame of reference? How would motion appear in frame of reference which is moving with the velocity equal to center of mass? So it is valid in that case as well. Okay. So this is something more like conservation of momentum. So this I've done in more detailed way. So I hope you understand. All of you have seen the formula, but this was why I dealt in so much detail. You get an understanding where this comes from and what are the terms here. So only thing what I assume here, the rate at which the air escapes is constant. Or if you have to calculate average force, anyway you can take this average quantity. Okay.
Sir?
Yes.
Sir, I didn't understand why we take the relative velocity as a constant.
Now, tell me. I think I have given. Why did I pick up the example of you throwing the ball? There's the reason I took up the example. Why the velocity of ball in the frame of trolley will remain constant? And if I take a gun, suppose you have a gun, and you are standing and you fire a gun, the bullet will leave a particular velocity. Let's say gun velocity is 200 meters per second. Okay. If you get onto a fast moving train and the train itself is moving a velocity of 100 meters per second, again you aim the gun in the forward direction. What is the speed at which the bullet will travel in seen from the ground frame? What is happening here? Both cases, see when the explosion takes place. What happens when this kind of explosion takes place? Impulse applied is constant. So in this frame of reference, change in velocity is constant. So with reference to the bullet, with reference to the gun, it will have a velocity of 200 meters per second. So here also, what is happening? Something happening to gun, bullet here. Similar thing is happening to the flue gas here. So unless mentioned otherwise, we assume there's a kind of combustion chamber. It develops same pressure. Because the same pressure, it escapes with the same velocity compared to the pressure chamber. Its velocity with reference to pressure chamber remains constant. Ground velocity may vary. But this is an important point, a simple point. It is useful in some of the little more complex question. I hope this part is clear. I hope
Yes,
all of you understood. Arij,
Got it, sir.
are you clear about this point? And this will revive it to remain constant. Okay. And and this is something. It sounds a little counterintuitive. So if leaves, it is possible to get a velocity even higher than this. And you know what will happen? So if Arij, if you understood, let me ask one more question. So if the rocket is moving in this fashion, it is having beta. Beta term indicates the rate at which flue gas is escaping. So that is the rate at which something like air escapes here. This value is constant, V relative is constant. Will the acceleration of the rocket remain constant? It will keep decreasing or it will keep increasing? How would acceleration of the rocket change if the rate at which the flue gas escaping is constant and relative velocity also remains constant? Will the acceleration remain constant, increase or decrease?
I think it'll remain constant.
That's not correct answer. Think of why not. Anybody else has a different answer?
It'll increase, right, sir?
Yes. Why?
Mass is decreasing.
Mass is decreasing. So force remains constant. So what happens when the rocket actually moves? As the mass becomes smaller, same force is acting. This force term here, are you getting this point here? This term remains constant and this force is acting in smaller and smaller mass. So it will keep accelerating more and more. Okay, that's the point you can get. So that's another way to understand that. Right. Now coming back to more easier questions. Okay, this question, I think some of you must have tried. Kathy, can you solve this question?
Sir, I'll try, sir.
Okay, you haven't tried yesterday?
No, sir.
Why did you not try yesterday? You said something I could not hear, Kathy. Why did you not try yesterday? Not getting time? Or you find it difficult? Okay, Kathy, Vikram. Vikram,
Sir,
can you solve this question?
I'm trying it now, sir.
Oh no, it should not take so much of time. And you haven't tried earlier, which is not good. Okay, let me tell you. Who else can support? Right. Lakshita,
Yes, sir.
can you solve this question?
I mean, by looking it, yes,
Hmm.
but I haven't really
Good.
solved the
I'm
word.
happy with that part first. Looking at it, you get a feeling when you look at the question and tell me which principle comes to your mind. How I'm going to solve this question. What I need to find? We need to find a police as shown, like the mass, its system remains in equilibrium. That makes it simple. We need to calculate angle theta. So what are the principle, what process are you going to use? Can you think of method to solve this question?
Yes, sir. Probably by looking at or finding the tensions there involved or the
Yes. So
forces.
can you, how many there strings are there in this case?
Um,
How many strings are there? See, each string will have a particular tension. How many strings
yes.
you notice? The
Um,
string means this is one string here.
yes.
This
One.
string all through will have same tension. There's another string connected on the right hand side, and that string will have this string is a different.
Another
So in
tension.
this string, so if this part tension is T1 here, even here also the tension has to be T1. Is this clear? And if this tension is T2, this tension also has to be T2. That's what it means. Each string will have same tension. And can you tell me what will the T1 be, value of T1 be? How much is the tension T1 here?
mg.
Mg. Because this is in equilibrium. So this one is equal to Mg. It's also equal to Mg. T1 is equal to T2. So I have got tension in the string is equal to Mg. Now I come to this point here. I easily find this theta here. Simply draw a free body diagram. On this block, mass is root 2m. Force is, if I draw the free body diagram, it will be like this, root 2m into g. And two tensions are acting. Both tensions are equal to mg. They are acting at angle theta. So can I find angle theta easily now?
Yes.
How do I find? Take the vertical component and equate. So vertical component will be equal to 2mg cos theta. Has to be equal to, so I am taking summation of force in y direction to be 0. That is has to be equal to root 2 mg. Very easily you can get an answer. So this question also is something which should be done in about a minute's time. Atri, have you understood?
Yes, sir.
Can you solve a similar question? Practice few more questions so that you are able to solve quickly. Okay.
Yes. Okay.
But two string tension has to be equal. Okay. Now coming to this question. All of, and this is point of contact B here, and this point of contact is A here. If I'm looking at this sphere, this height from here, this particular thing is 3 meter. If this is 3 meter, this angle has to be 37 degree. It means this point is 37 degree, and this one is 4 meter. That's what the figure says. This is 4 meter. And this is 5 meter radius is given. So this angle has to be 53 degree. So what is the important point here? The important point, I think some of you may miss sometimes. So whenever there's a contact here, two forces are acting. Which direction surfaces are smooth, force will act along the common normal. In this case, this is sphere. So this force will be acting along the normal direction. It will direct towards center. That would be the contact force at A. Similarly, contact force at B also will act towards the center. That's the only point. So three forces acting in all. Mg, this and this. Once we have all these forces, resultant is 0. So if I draw the free body diagram, you can think of it also. It's very simple. And some of you want to understand even, so there are like 3 vectors. If I represent 3 vectors in form of a graphical method, all 3 vectors put together should form a closed polygon. So that also something, let's see how do I use that part also. That's another way you can think of. One is if I draw free body diagram, this part is mg. And then we draw this one. at a 53 degree from the horizontal, reaction at A, in A, 53 degree, and B is 37 degree from the horizontal. That's NB. So we have two unknowns and two equations. So if I take this as X direction and this as Y direction, we need summation of force X component equal to 0 and Y component to be 0. So what we do, we can express in the form of their component. So those who are still struggling with basic, if this angle is 53 degree, so this will be equal to 0.6 NA and this will be equal to 0.18 NA. And similarly, this will be equal to 0.8 NB and this will be equal to 0.6 NB and weight will be equal to 100 Newton. That's when we can form two equations you can solve. You can also, like, I think this is just see where some of you might be interested in learning that part also. I can represent these three as in form of a graphical way. So if I draw first one, so first one will be like this. This is 100 Newton mg. I have drawn a vector of magnitude 100 Newton vertically downwards. Then I draw the second vector at an angle of 53 from here. This makes an angle of 53. So I draw the second vector at angle of 53. This is how NA will be equal to. And I draw from head of this vector the third vector, which is NB. And this angle from here, this is 53 and this is 37. This angle becomes 90 degree. And this is NA and this is NB. If this is 53, this is 37. So from here, this is 100. What is NA equal to? NA is equal to 100 cos 37 and B will be equal to 100 sin 37. So this also, Lakshita, have you followed what I have done here?
Yes, sir.
You can also draw a vector polygon, which is a vector triangle, and sometimes it's much easier to solve, and this gives you another way to analyze a question. You can have done this way, we can do this way as well. Just have you followed this?
Yes, sir. Yes, sir.
What is the important point here? We should never miss, if it's smooth surface, contact force is along the common normal.
Common normal, yes, sir.
And so that's something we should understand. Simple question also. Next question. What is the angle between these two vectors? This and this angle is 120. Of course, when three of them form three vectors of equal magnitude, if the resultant is 0, they are placed in a plane. Angle between them has to be equal to 120, 120, 120. That's where you can solve, or you can resolve it also. Yadeep?
Yes, sir.
Are you following this also, what I'm saying?
Yes, sir.
Why 120? Is that clear?
Yes, sir. Got it.
This question now. Okay, I think Vignesh, have you solved this question as well?
Yes, sir.
Did you have any difficulty?
No, sir. Like, I mean, I don't know if it's a shorter way, but I had to find even sine 74.
No, not necessary. Think of it. Let's see what is the other way we can solve. Okay, so there, see, okay, sine 74 not necessary. So what we say here, let's do by step. How do we go about it? So this is something. What are the forces acting? A sphere of mass m is held between two smooth surfaces. Again, smooth surface mean yes, it will act only normal to the surface. So one reaction N1 here is acting like this, and N2 is acting in this direction. It will always be pushing kind of force. This is the direction of N2. Let's try and understand these directions also. Basically, there are three forces I need to draw. And I'll come to this one. How do we solve this slightly easier way? Vignesh, you pay attention, because since you missed out that point, and sometimes we can learn few things you also. So very easily we understand here, if this angle, if the plane makes 37, is normal will make same 37 in the vertical. Let's say the perpendicular will make whatever angle is tangential, so this angle will be 37. This we know already. Okay, and from here this angle becomes 74. That's where Vignesh, you said you had a little problem. Okay, so this angle is of course 74. Total angle is 90. So this angle has to be 16 degree. This angle has to be 16 degree. So we understood the orientation of all three forces. This is vertical. This is making a 37 degree anti-clockwise with upward vertical. And this one is making angle 60 degree down from the horizontal. So let's represent these three forces. These are the forces here. This is mg force. This is my N1 reaction. Sorry, this one is my N2 here. So I have put all the tails together at the origin. And this is N1 here. Let me mark the angles also. N1 is at what angle? N1 is, sorry. N1 makes an angle of from here. This one makes an angle of 37 degree. And this makes an angle of 16 degree. What is required to find? I am required to find only N2. We need to find the normal reaction at wall 2. So just how do I make my calculation simpler? So I am not interested in N2. If I can write an equation which has only N2 and mg, not N1, then I can solve in one step. How do I write an equation which does not have N2? So if I choose an axis which is along N direction, so let me define this axis is X. Okay. So what I do here, perpendicular distance Y. I take summation of forces in Y direction to be 0. Summation of forces in Y direction to be 0. In that case, N1 will not have any component. So I have taken, since I have to find only N2, I am writing an equation so that N1 does not figure in my equation. Now, component, if I have to write, all I need to know this angle here. Okay. What is this angle? This angle is 37. So this angle is 53. This angle is 53. So what is component of mg along y direction? It will be equal to mg sine 53. What is the component of N2? This angle is 16. So what is this angle here? I need this angle for finding component of N2. I need this angle. How much this angle will be? Yes, Abhiru? Yes.
So that angle will be 37, right? The one you wrote as 53.
Sorry, by 1 minute. I correct that one. Yes, angle will be, just writing something written down. This angle is, yes, this angle is 37 degree. Yes, this angle is 37 degree. And this angle is 16 degree. What is this angle here? What is this angle? I need angle of N2 from x-axis. Total angle is 90. 90 minus 30 is 37 minus 16. How much I am left with?
37.
37. So when I take the y component, are you following this? What is the advantage of this method? Abhiru, have you followed what is the advantage of this method?
Yes, sir.
I don't have to find N1. So since both are making 37 degrees, straight away I know N2 has to be equal to mg. That's my answer. So Vignesh, so 74 you don't have to deal with.
Yes, I got it, sir.
Got it. And so see, sometimes even simple question also, that's why I say, don't just solve the question, look at all possible ways we can solve it. Manish,
Yes, sir.
you understood?
Yes, sir, I understand.
Direction part, are you clear that this force will not be up? Sometimes you don't mark like this. If you mark wrong direction, the force will be always directed into the body.
Yes.
Contact force acting on the sphere, the direction has to be like this. If you do it properly, you get your answer. Next question. And this question also, this is kind of question, again, you can solve in about a minute's time. It doesn't take any time at all. Let's see how do we spot what is the method to solve this question. And there are other variations of this question also. Find the normal reaction exerted by the inclined plane. Okay, and since we are almost running time, I say without just looking at the question, I say this each reaction will equal to 3 mg. Why would each reaction be equal to 3 mg? I'm saying this also will be 3 mg. This also will be 3 mg. Because there are also three forces here. Gravitation force 3 mg. And if I call this reaction is N1, and if I call this reaction is N2, quite clearly because symmetry, N1 has to be equal to N2. And so if I draw in terms of vector figure, if this is my mg here, 3 mg here, this one acts at angle of 30 degree, this acts at the 30 degree from the horizontal. So this force, if moment I draw this force, I know angle between two vectors is 60. So it will form equilateral triangle, and moment it forms equilateral triangle, all of them have to have same magnitude. Or otherwise also we can solve. What is other way kinds of free body diagram if I draw? If I take all three as a system, we'll have three forces acting. What are three forces acting? One is weight, 3 mg is acting downwards. Then reaction N1 is acting an angle 30 degree with the horizontal. So 31, this angle N1 here is acting at 30 degree. And this N2 also is acting at 30 degree. So another way to understand here, moment both angles are 30 degree, they have to cancel each other. N1 is equal to N2. And their sum of vertical component has to be equal to 3 mg. That's also we can solve. And little more complex part of this question is what happens if we start reducing this angle from 60 degree. At a particular angle, what will happen? This will not remain stable. It will start spread out. What is the maximum angle at which it will remain stable? It is a little more difficult question. Okay, so I'll stop here and I'll continue with some more. I'll continue the evening session. I will pick up some more examples of constraint motion and slightly new concept as well. Not new concept, new ways of solving question as well. Okay.
Thank you.
Thanks everyone.
Thank you, sir.
Thanks everyone.
Thank you, sir.
Thank you.